Distributech 2023, one of the sponsors of these interviews, and these are interviews with thought leaders from around North America and the globe. Our sponsors are H2 Scan. H2 Scan is the leading sensor manufacturer for hydrogen sensing in a lot of different applications, in transformers, in battery room safety, in processes in safety, in industrial, and in the future hydrogen economy. So I want to thank our sponsors, and I want to thank all of our guests, and I hope you enjoy this interview. My next guest is Ben Lanz. Ben is a delight. He's a friend, so we're going to have a great time doing this. But Ben, what is your title now at MCOR?
Director of Strategy and Development.
I love Director of Strategy. And that's why we have such a good time, because we think differently, the same. We think differently, the same. But Ben, thank you for joining me. Okay. First of all, tell me how you got involved in the power industry and how you got involved with MCOR.
Yeah, well, the initiation was as a young boy. I actually started in the trade with my father, doing electrical work, hands-on, learning the tools. I put myself through school using the tools as an electrician.
As an electrician?
As an electrician.
Oh my
That's
gosh,
right.
I did not know that.
That's right. And then when I met the professor, Dr. Matt Mishikian, at the University of Connecticut Insulation Research Center, and he was a very hands-on type of guy, came from the utility industry, and said, I've got some ideas that could really change the industry. It really inspired me to jump in. And then when I met a host of individuals within the industry who knew so much, it seemed like a really great opportunity to make a difference. So my trajectory has been people. You know, we got talking just before this interview about people, and it's people, right?
Yeah.
You know, the man, Dr. Matt Mishikian, we had an article here at APC Magazine about him as an industry thought leader and really trying to inspire others, and that story inspired me to do what I do today.
Yeah. We're going to come back around to that, because one of the things, the utility industry has been very staid. It was never thought as being that inspiring, right? The fact that the utility industry is actually decarbonization. We get to do that. We're adding wind, solar. We're adding all kinds of new things. We are responsible for the electrification of transportation, and potentially responsible for degasifying our houses and things. So there's a lot of things. So where you were inspired because of, hey, it's change, we've created an area where we can actually recruit people and say, come into the industry, make a difference. Research tells us that 10 years ago, the number one thing that people wanted as a job when they were in their 30s. Now we're talking about the professional. They're not just coming out of college. Number one thing they wanted, pay, benefits, job security. They were the big three, right? Do you know what number one is today? I want to make a difference, but I want good pay, benefits, and job security.
Sure.
It's not that they go away, but they become hygiene factors, because everybody will pay you more. There will be job security if your security's in your career, right?
Absolutely.
And people realize that there's not loyalty in most companies anymore, right? But what an interesting thing you were inspired to come into. It's a perfect example of what we're going to have to do to recruit that next generation is. Make it something that says you can make a difference. So, well said.
Right,
okay.
Absolutely.
Now what I want to do, you and I have pontificated a lot about what the problems are of the industry. Sometimes 2 years ago at this event, IoT was everywhere. You don't see IoT anywhere. A year ago it was drones. You don't see drones anywhere. It's not that they did not get adopted. They got adopted pretty quickly. Right. In fact, their adoption created more problems. Data, lots more integration problems, things like that. But as you've been around the industry, we're a year from COVID. Supply chain was the whole issue at COVID, about post-COVID. It was all supply chain. It's not that issue's gone away, but at least we've begun to mitigate it, right?
Right.
What do you think are the major new challenges that the utility industry is facing?
Yeah, I think from my perspective, I see that the industry is driving, there's a focus on electrification.
Oh yeah.
And obviously, like you said, the supply chain didn't go away. We heard one utility one of our client utilities was able to get 40 transformers from a source across the ocean, and they use about 80 per week usually. So, I mean, so the supply chain has not gone away.
Yeah, okay, right.
But like you said, as we have started collecting tremendous amount of data, the data can be our friend if we can organize it. And so I can see what we've done as an organization, a company in particular, ImCorp. A couple years ago, we were engaged with an organization called the MathWorks and MATLAB.
Oh yeah, MATLAB, MathWorks.
Yeah. Right, and they had a gentleman who came out of the Watson program, IBM Watson, and we collaborated on deep learning. And this was already 6 years ago that we were starting to work on this, and it's to the point where now we're using deep learning and AI to do what humans were doing. In fact, we have hundreds of thousands of cable systems that we've assessed, these large data sets, millions and millions of data points, which literally would take humans years to reanalyze, like a decade to reanalyze with the same team. We can now analyze that entire data set in 36 hours using web services. So there are solutions, but we can't necessarily just sit and wait for the solutions to come. We have to use the tools that are coming at us, because the challenge is with electrification, we've got the supply chain issue, we've got scenarios where people are needing to make complex decisions, right? You're saying, well, we're going to put systems underground because we're going to protect against wildfire, or 30% of the populations are on the coasts, and we're going to need to put those underground. So you're going to want to upgrade those assets so they can handle the electrification. And you have to make decisions about installing those assets, but you want them installed properly. So you need to actually have a process where there's quality control. Well, in order to do a quality control assessment, that requires a technology that can provide a meter by meter profile of that asset. That means a ton more data. And now we want to take that data and create a baseline so that if there are issues further on down the road, we can then use that data to say if we have duty cycle, so transients and high current application on these underground systems, that we know deteriorates those assets. But if we have a baseline from day one, and we have assets that see these extreme conditions versus assets that don't, that's information we can use to make better asset management decisions. So not only is there more data and more decisions that need to be made on the investments that are being made now, but we also have an opportunity to collect this data and process in a way that's going to help us in the future.
That's excellent, because I hear a lot of people talking about big data as a problem. You just kind of presented big data as a solution, right?
It's an opportunity.
Well, it's an opportunity, right, which means it better be a solution, because right, if not, we're going to be awash in it, and people are going to make bad decisions just because of data. There's another thing, data, you mentioned AI. And even here, we used to, 3 years ago, AI was everywhere, and now you don't hear it. But the adoption of AI starts with the adoption of machine learning. You know, you got to start with the data. I love I use this, and it's probably not true, but I use it anyway. You give me 1 point, I can't tell you anything other than that's 1 point. Right. You give me 2 points, and I can give you a line. And I can begin to tell you, give me 3 points, and I can extrapolate and tell you exactly what's going to happen next. Now, that's not true. We know that. Right. But we love data. We love data points, and the more should give us a much narrower decision matrix. Hey, this is the narrow band, right, and now you're outside of that. You're in an anomaly state. Right. I can't tell you what happens in an anomaly state. You're going to miss the moon. That's right. I can tell you that you're not going to hit the moon with the, the trajectory. But fascinating. One of the other things that's happening, we just got an updated report from Bloomberg, and it was on their initial, and I say initial, they update this, I think, almost quarterly. Their last quarterly update on the adoption of EV in the United States, in North America, was X. Now they're saying, oh, by the way, we were 2.4X off of X. Okay, it's going to be 2.4 times that. Well, suddenly that changes. If you're in a utility and you go, wait a minute, what does that mean for me? Right. You got to then say, what does that mean for me? If you're in California, right, it means a whole heck of a lot, right?
Right.
So the idea that things are changing so rapidly that causes me to make decisions about my grid, about how I make power, buy power, use power, get power out to the grid, are going to be more complex than ever. So there's going to be new data, more points. We just changed the data on adoption by 2.4 times. And I'm not saying Bloomberg has got it perfect, but they've been pretty well right on track for many, many years.
Right.
So we go back to data, but prior to data, you got to have somebody who is willing to take the data, take a recommendation from the data, and make a decision, right?
Right.
Let's talk about people. That's what we first started with. The industry's got a real problem. Well, I mean, we've got to bring more people into the industry, prepare them quicker than we ever did before. I mean, the idea of bringing people in and running through a 3 or 4 year training program doesn't quite happen anymore. It's like we might run a college student through that for over their 3 or 4 years as an intern, but you better be up and running and working and giving me value, because guess what? If it isn't you, there's nobody else to give it to, because the guy that did it before, he's gone. He's fully retired.
Right.
All right. How are you seeing and how are you all at IMCOR handling the idea of people? Because you're a growing company.
Yeah. Well, I think one of the challenges is the lack of information or lack of experience, and being able to take large data sets of information. You know, for example, I said we have hundreds of thousands of cable systems that we've profiled the condition of, and we've done thousands of dissections. And we've actually investigated cases where there have been, say, faults, doing investigation on the root cause of that. So we're pulling that knowledge base together, and so as a company, we're sharing that information so that people become more knowledgeable, but we're also packaging that information in a way that, for example, AI can use it. Whereas it might have taken an individual who, knew that, well, that old unjacketed concentric wire neutral cable that was directly buried, that's the asset that has the problem. Now, because we have the data and we can build a knowledge base on that data, it's no longer the person who remembers what happens. We've got the data and the knowledge base to drive people's decisions. They don't have to, say, relearn that themselves, right? So I see data and what I call a knowledge base. For example, just take one example. If you look at some data, if you have a cable system that fails and it's already, say, 20 years old, the likelihood that that's going to fail again, the data shows that it's about a 10x increase in failure rate. And why is that? Well, it's an actual fault location process. It's the humans that are damaging because they didn't know that the process they're using is damaging to aged cable. So there's a knowledge there, but what about using technology to remove the likelihood of the fault to begin with? So we're going to use that knowledge to say, well, that's another reason why we should be testing the system to begin with, because the vast majority of faults, even 30 to 40 years down the road, have to do with the installation process or issues that existed from day one. So that's where the knowledge base, that data, that knowledge can make recommendations, and now we can provide those recommendations to, say, people who, again, don't need to live or don't have to have that 30 years of experience because the data is available. It's not just enough for utilities to say, we had X number of assets fail and a certain failure rate of a certain vintage. You really need to know root cause, and that's where, say, a technology like what we're using at IMCOR that can provide a meter by meter profile. Now you have a feature-rich information that can drive much better decisions moving forward, because it's not just a failure data point, it's this specific component, and here's the reason why.
You and I talked about, I think you did a case study on this. It's a utility, we won't name the utility, but you did a study for them, and they were going to spend X amount of dollars replacing cable, and you all came in and using data and using testing and looking at it, you saved them a boatload of money. to not replace cable that didn't need replacing because it was not the problem. The problem was the human error and on either end of that cable. I can't remember exactly the specifics of it. Do you remember that?
Oh, absolutely.
Right.
There's not just one. There's actually several.
Well,
right?
tell me one of them. Tell me a new one.
Okay, sure. So there's small specific case studies which provide, I think, insight, and there's also large. I mean, there's I would say a large-scale study is like maybe 50,000 cable systems over the last, let's just say, last decade, maybe. Okay. There's other cases where it's maybe just a smaller section of cable systems. For example, there's a utility that had. We had a polar vortex come through, and they knew specifically that they had run some cables with a much higher load than normal. They heated them up. Right. They knew that the assets in there, the type of product they had, that once it goes through that heat cycle, it expands and it doesn't contract very well. So there was some loose-fitting components, but they don't know which ones actually had the issue. So with that knowledge and knowing that product, again, with our knowledge base, we could say, oh, those are assets you're going to want to go through and profile again. So that's just one little anecdote. There's other cases where, again, it's tens of thousands of cable systems where they said, well, we have everything beyond a certain age and of a certain number of failures, we're just going to replace it all. And of course, that's cost prohibitive. And we know that not all those assets are bad.
Right.
We know that it's just one spot here or there where there's been defects, and many of which have been introduced. And so, absolutely, one utility was able to drop their failure rate by 20 times. They dropped the failure rate by 20 times. The aged assets were outperforming some of their new assets. By how? By removing the defects that existed and then putting overvoltage protection to make sure that the system, due to system transients, wasn't introducing new defects. And that, of course, saves hundreds of millions of dollars over just a couple-year program.
Yeah. Lastly, I want to go to IMCOR. People may not know what you do, so if you wouldn't mind kind of sharing a snapshot. But more importantly, as head of strategy, where are you going? What is it going to look like in 5 to 10 years?
Right. So our technology and our process has been very human-based, and there still will be an element of that because you need humans in the field to make sure there's safety, and you need humans in the field to help guide other humans, right? But as it relates to the technology itself, the ability to produce what we call a factory comparable test, a test that can reproduce what's done in a cable and accessory manufacturer's plant in an electromagnetically shielded room, this technology can reproduce in the field on a meter by meter basis. And the data coming in, making sure that that data is of high quality, and also that it's analyzed right there. With the fact that you have now 4G and coming 5G in many places, especially in city areas, the access to huge processing power is so much easier. So this technology, with the help of AI and machine learning, what we call deep learning, which is, my understanding, is the next level of machine learning, is going to be able to simplify that process so that you're going to have much more immediate results in the field. So you have a thorough analysis in the field when you're doing the test. It's not just a cursory analysis, but then also you're going to have a scenario where you're going to be able to use this condition-based information and compare it to other pieces of information, which may be the number of transients that you've had on a certain line, or if the system's been overheated. These are the primary drivers of cable failure, and marry that with asset data. So for example, if I have 100 aged cables that have roughly the same performance, and yet these assets over here are seeing multiple transients that are driving those failures or those defects to failure faster, harnessing that information through online sensors. There's numerous companies that are offering that data. One of our clients has tens of thousands of these sensors installed, marrying that information is going to narrow the assets that need to be addressed. With the traditional approach of the age and failure rate, you can maybe give an 80-20 rule. 20% of your population is causing 80% of the failures. You do a standardized test, you might be able to drop it another 80%. So now you're dealing with another fraction of 20-80 rule. And then finally, the idea is to continue to narrow that down so you're using information to make more and more precise decisions. And this is going to become more and more important as more of our assets are depending on electrification. More of our life is depending on electrification. And the utilities cannot continue with all the competitive scenario. They can't continue to just say, well, it's an old asset, we're just going to replace it. They're going to have to make better decisions based on information, and that information is going to be huge, and we're going to need these types of AI-based processes to narrow it down so humans can make the decisions. And again, humans still going to be involved. They're going to say, the line crew that's supporting this process, this is the way we need to do it safely. Okay, we're going to work together to do safety. That's human to human. And then we're also going to be human to human. Here's how you need to correct it. So when you cut open this termination, this is how you fix it. That's a human conversation. That's not going to be a machine doing that, at least for now. But the machine is going to help us make better decisions in that area.
I used a rotary dial phone. Remember those? Right?
Oh yeah.
I used rotary dial phones. I use an iPhone now. I liken the transition that we're doing to that kind of a transition. I mean, that one was just you dialed some numbers and you had a person on the other end. This one, oh my gosh, I can talk to my son in London, my wife in LA right now, and I can do so much more. I can, I have the power of a computer in my pocket. And I think that kind of a sea change is happening in the utility industry. And it's going to be things like you're talking about that are going to make that happen, or else we're going to get stuck. We're going to depend on the humans solely, and we're not going to have enough of them doing the right things, trained enough. We've got to capture the legacy knowledge, but we've got to better capture it in a data context, as opposed to, hey, call Larry, he knows, right?
Well, I mean, you look at some of the old-time pictures, and you'll see people coming out with even a tie on, right? They're out in the field, and these are artists, and they're amazingly focused on, from a knowledge base. Their craft and their experience is incredible, and we don't have that.
Yeah.
We need tools to help us to get to really the same level or even better performance with a lot less cost. And I think these kinds of tools are going to help us get there.
Exactly. Ben, it has been a delight. I always love talking with you, my man. You get my head. I feel like I got corpuscles expanding here, but thank you so much. I appreciate it.
You're welcome.
This has been an APC Technologies production, and we thank you for joining us. Our sponsors have been H2 Scan and Distributech. And of course, the communities of APC Technologies, which is Transform Technology, Power Systems Technology, Green Energy Technology, and Women in Power Systems. So thank you.